Greetings and welcome, friends. Today we are learning an additional technique for solving the same type of problem that we learned about last section. We've been talking about solving systems of equations, and when solving them graphically, we've already recognized some weaknesses to that strategy. It's not the most accurate, and if my solution wasn't near the origin, say it was like my answer was like 1,273, 5,142, I would just be like, have a really hard time graphing that with any amount of accuracy, right? I would have been aiming my graph near the origin and would have been super far off. So today I'm going to show you a far more effective approach that is super accurate. It's going to be amazing. Amazing. It's called solving by substitution, and it plays off of the principle that if two things are equal, I can interchange them at any given time. I'm not even going to read these steps yet. Let's do these steps. All right, let's do these steps because otherwise they won't make a lot of sense. Step one. All right, and it's not even a bad idea to label your steps. That might be a good idea. Step one says solve one of the equations for one of the variables. All right, notice it's a system because I have two equations. When I'm looking at this, I'm going to want to solve for one of the variables, but behold, the first equation is already solved for y. Step one is done, son, right? Step one is done. Now, the benefit of solving for one of those equations is in step two. It says substitute the expression from step one into the other, keyword other equation, highlight that if you need to, and solve for the other variables. So check this out. Here's the substitution part. If y is really equal to negative 2x minus 9, then that means I could interchange this with y anytime I want to. So that's what I'm going to do. That's the big substitution idea. All right? If these two things are equal, I can exchange them, replace them anytime I want to, and this equation would still be true. So 6x minus 5, and instead of y, I've got to put parentheses here because that whole Indiana Jones analogy, remember he put the sand in a bag. He didn't just throw a bunch of sand on the ground, right? No, he put it in a bag to keep it together. We got to plug this in its parentheses bag to keep it together. So instead of y, it's negative 2x minus 9, and then keep going, equals negative 19. Sometimes people forget to write the rest of the equation because they were so excited about the substitution part. Okay, and what was the end of step two? It says solve for the other variable. Notice, this made this problem look uglier. There's a whole lot more going on here than this original equation had. But what is the benefit? The benefit is that it is all written in terms of a single variable. We, from our chapter 1 experience, know how to solve an equation when there's a single variable in it. I don't know how to solve an equation when there's multiple variables in it, at least not without having to write it in terms of other variables. So now that this has a single variable, let's solve. So write this down, friends. Let's simplify. Distribute will be my first move. And let's see. So I'll have 6x plus 10x. Yeah, that double negative. Negative 5 times negative 9 will be plus 45 equals negative 19. I like it. Okay, still solving, still solving. I think I could bring those x's together. Do you guys remember what that was called? What was it called when we'd bring those together? Combining like terms. So if I have 6 x's and 10 x's, how many x's do I have together? 16x. Yeah. Actually, Mr. Waddy only has 2 x's. He hasn't dated a whole lot of people in his life. But I'm very happy now, so it's okay, right? I don't need 16 x's to figure out who the right person was. Let's see. Now we can keep solving. How do I get this x by itself? I think I want to get rid of this before I try dividing. Yeah, right. It's not wrong to divide first, but it's just going to create some weird-looking fractions. So let's see. These cancel out. I'll have 16x. Remember, we keep our equal signs all lined up? I love it. Negative 19 and negative 45 is becoming more negative. Negative 64. Okay, now what do I do to get x by itself? Yeah, the inverse of multiplication is dividing. And it's going to be almost -4, -4. So guys, so this is, wait a minute. Guys, wait a minute. This isn't my answer. My original problem had x's and y's. This is just x. This is only half of my answer. Half of my answer. Okay? So I still got to figure out what y is. I'm halfway there, right? So step 3, let's find out. What did step 3 say? Scrolling on up. Yeah, substitute the value from step 2 into any of the original equations. All right, so watch this. Watch this. We're doing substitution again. If x is equal to -4, then that means I can plug this in for x. I could plug it in here if I want and solve. But even easier, why do you want to do the first one? It's smaller numbers, and notice this first one is already solved for y. Yeah, so that's going to be way easier. So y equals -2, and instead of x, I'm plugging in -4 minus 9. And look I don't even have to solve this. This is just some PEMDAS. -2 times -4 is +8. And y equals -1. So my solution is x equals -4, y equals -1, or I could think about that as the ordered pair -4, -1. Oh, like if we hypothetically plugged it in here? I won't take the time to do that right now because I want to get to a whole bunch more problems like this. Thanks for hanging out for at least that part, for the intro. Let's do another one. Now the beauty of this is if my answer was like pi, comma, the square root of 7, I can get the exact answer every time using substitution. Whereas if I was solving graphically, I would never, ever get something so precise. Let's see. Let's try both of these maybe. Let's do monitoring progress question 1, which looks like this. I believe you already have it in your packet. So you can write this down. All right, step 1 said solve one of the equations for one of its variables. Notice, both of these equations are already solved for one of their variables. What variable is it solved for? Y, because the y is by itself on its own side of the equal sign. So step 1, it done be done again. Thanks, book, for giving me a problem that's partly done. Step 2, we're going to plug it in to the other equation. So if y is equal to this, that means I can replace y with this at any time. Right? Like Indiana Jones exchanging a bag of sand for a golden idol. So here we go. Let's replace y in the other equation with 3x plus 14. So 3x plus 14, in this case, I actually don't even need the parentheses around it because this was just like 1y. If it was like 2y, then I would need parentheses, so I'd remember to distribute. But we can just drop those parentheses right off the bat. So 3x plus 14 equals -4x. And now we solve this remaining equation. What's the good news about this equation? It only has one variable. Right? That's the good news. We know how to solve those back in chapter 1. And even if we don't remember, we're getting the practice now, so it's good news. Normally, I would always move the little guy to the big guy, but I think I can actually save a step by working with negatives for a little bit. So I'm going to bring my x's together. Could someone actually pause? Why can't I just combine like terms right now? They're on different sides of the equal sign. Yeah, I can't just combine those. I got to bring one over to the other side. So I'm going to have 14 equals -4x and another -3x is becoming more negative, -7x's. How do I get x by itself? Divide, right? Devin's writing this down. He's texting his friends about substitution right now. He's like, you got to check this out. This is amazing. And it is, right? All his friends have been solving systems by graphically. Ethan's messaging all his friends on Google Chat. He's like, guys, you got to check out this substitution thing. Mr. Waddy's going to post this video probably in another 40 minutes. It's going to be amazing. Look out, right? So wait a minute. Oh, wait, we are not done. We are part done. I only found X. I need to find Y. So watch this. I can take this and plug it in for X. Which equation do you want? Yeah, I agree. Let's plug it into this equation's X. But you'd still get exactly the same thing if you plugged it into the other. So step 3, plug this answer into one of your original equations. And I'll have y equals -4 times -2. And then solve for your remaining variable. Y equals, yeah, +8. Yep. Now they then asked us to check our solution. Sure, let's do a check. We'll call that step 4. If my solution is -2, 8, right? Or x equals -2, y equals 8, same thing. Graphically, that is the intersection of these two lines if I was to graph that, so you can kind of connect it to your previous concept. Let's do a check. So let's check the first equation. Is 8 equal to 3 times -2 plus 14? 8 is that equal to this plus that, and 8 is equal to 8. It works in the first equation. That means that -2, 8 is a point on this line, but we still got to check it in the other for it to be a solution of the system. So y equals -4x is now 8 equals -4 times -2. And hey, what do you know? 8 equals 8. Cha-ching, cha-ching. It worked in both, and therefore it's a solution of the system. Right? It's got to work in both. We found the one point, like the holy grail of all infinitely many points, that happen to make both of these equations true at the same time. Isn't that amazing? Amazing. It's amazing. Here, let's do monitoring progress question 3. I wonder if I did this one last semester. Doesn't matter. It's a good one. All right. I like this one because it gets us thinking in terms of another variable. And then I'm going to get you guys plenty of practice on this. We'll do this one, and then I think example 2. Yeah, we'll do example 2. Good. Question, comment? All right, guys, step 1. Solve one of the equations for one of its variables. Oh no, none of these are solved for y. But wait a minute. Wait a minute, friends. Equation number 1 is solved for x. So step 1 is done. Now, step 2 is the substitute step. If x is really equal to 6y minus 7, then I can plug this in here? No, you could tell by the inflection of my voice, the way I was asking that. Ethan's messaging his friend still. He's saying, do I plug it in for y, guys? Do I plug it in for y? And no, we don't. This is equal to x. So I'm going to plug it into the other equation's x. So 4 times, instead of x, I'm going to put parentheses, right? Plus y equals -3. And what am I plugging in instead of x? This entire expression, 6y minus 7. And now we solve. What should I do to solve this? Let's distribute. Whoop, whoop. Multiply 4 by everyone in the parentheses. 4 times 6y is 24y. 4 times -7 is going to be -28. Did I do that right? We can then combine like terms. 24y's plus, how many y's is this? Yeah, a little invisible 1y. I agree. Is 25y minus 28 still hanging out? Equals -3. Now what do I do? Add 28. See our solving skills, they're coming back. They're coming back. 25y equals 25. Hey, those are nice numbers. But even if they weren't, I could still get a precise answer as opposed to solving graphically. Right? So y equals what number? 1. Oh, so I solved for y, so I'm done. Wrong, Mr. Waddy. Wrong. That's only half our answer. What should I plug this in for to solve for x? Which equation? Let's see, Amity's talking to friends now too. Ethan, you can shut that down, Ethan. Yeah, where should I plug this? Which equation's better? The first one is better because it's already solved for the variable I'm looking for, right? Yeah, so that's better. So step 3. And I really do recommend you label your steps tonight because otherwise you're just going to get lost in the mathematical forest. So x equals 6 times 1 minus 7. X equals 6 minus 7. X equals negative 1. So my solution is negative 1 comma 1, right? Because x always goes first. All right, let's look at one more type of problem, and then we're going to class quest. Class quest. We'll go on adventures with some friends or some enemies. All right. Even though this has a lot of steps to it, how are we feeling so far? Awesome. Awesome. All right, here we go. Finally, we get to do step 1. All right, we get to do step 1. What is step 1? Solve one of the equations for one of its variables. So let's see if we can do some targeting. Targeting. Should I solve for this? No, that would be a bad choice. The reason, Cameron, I'm not solving for this x is because in doing so, at some point I'd have to divide, which is going to create fractions. So the ones you want to solve for, are going to be any of the variables that have a positive 1 or a negative 1 coefficient. Right, Devin? Devin! A positive 1 or a negative 1 coefficient. And if I have a choice, let's just go for one of these positive values. So, I don't know, let's solve for the first equation's y. But if some of you chose to solve for the second equation's y, it doesn't matter. We'll all still eventually get to the same answer. Okay, so let's do step 1. So if negative x plus y equals 3, how could I get y by itself? What could I do? Everyone should be writing this down. I want to move this. How do I move a negative x? Yeah, I got to add x to both sides. I'm going to get y equals x plus 3. This is the end of step 1, which we need to remember for the beginning of step 2. This is sometimes called, I'll write this down, but you don't need to know its name. This is sometimes called the, I can't even spell, the revised equation is what that's called, but you don't need to really know that name in my class. So if y is truly equal to x plus 3, then that means I can plug this into the other equation's y. Key word here is other. It has to be the other equation. If I plug it back into the first equation that I solved, or whichever equation I solved, I will get a false conclusion. I will think something is the answer, and I will be wrong most likely. All right, so let's plug it in. So 3 times x, I don't need those parentheses, plus y, which is now x plus 3, is equal to negative 1. What should I do to solve this? What's a good idea? I'm clicking on the green color in case that will be... You could minus 3 from both sides. I'm going to first combine my x's. How many x? 3 x's plus how many x's is this? That's an invisible 1 there, 1x. 3x plus 1x is 4x, yep. And yeah, and then subtract 3. You're not wrong if you subtracted 3 first. I wouldn't mark you wrong on a test. We'll all get to the same answer eventually if we obey the laws of math. These 3's cancel out. 4x is now equal to -4. Then that's when you make a mistake. Then you were actually obeying the law of math and everyone else wasn't. So let's see, x equals -1. Now step 3, I'm going to show you an easy way to do this as well. The book's instructions say to plug this into any of the original equation. But watch this. Every time, plug this into your revised equation. Because notice, I still need to solve for y. Gentlemen, eyes up here. Amity, eyes up there, right? Literally like no one's looking at the screen right now. There we go. Devin, I do my job, you do yours. Y is equal to -1 plus 3. If I plug it into the revised equation, it will always already be solved for the other variable that I'm looking for. So rather than having to do some more solving, take the easy way. So instead of x, I'll plug in -1. -1 plus 3, y is equal to 2. So my solution is -1, 2. All right, well, thank you for watching, Internet friends. Have a great day. Bye-bye.